Assalamu alaikum. Hello everyone. How are you? So in this video, we are going to design two unit cells that have the 180-degree phase difference that you can use for coded Metasurfaces. So I'm going to start with this. First of all, I will design with the 0-degree phase, or it is the phase is actually the difference. So any phase, if I have 0 degree, the other one should have around minus 180 or plus 180. So first of all, I'm going to do design one, and then I will just change the parameters, and then you will see there will be difference in the phase and amplitude, which you can further use for designing your arrays. So let's begin. First of all, click on the brick and press escape as substrate. So first of all, designing the substrate, the dimension will be a cross a, so a by 2, a by 2. So I want to just centralize it, so that is why I'm just doing like this. So the width, the height of the substrate, I want to just bring it down and to the maximum 0. So the substrate I'm going to use is Rogers 5880. I think the name is 5880 lossy. So let's preview. The value of the A is 5 mm, and the value of height of the substrate is 0.508 mm. So yeah, it is. So it is started here. Okay. So let's remove the working plane so it is better. Now we will just make the ground. So for making the ground, click on the brick again and press escape. Click on ground. That will have the same dimension as the unit cell in the x and y axis, because it is a reflective Metasurface, so it will be complete ground at the back side. So the height, okay, the height will be minus h minus t. The t is the thickness of the cladding, that is 0.35 micrometer, that is 0.035 mm, and the maximum dimension will be minus h. From minus h to minus t. So from minus h to minus h minus t, this will be. You can preview it like this. So t is 0.035. Oh, you can see it here. So it is correctly. You can just check it if you are doing anything wrong. So I will just change the material to copper annealed. You can also use a PC or the copper pure, but for if you are going to fabricate it and you want to similarity in the results, you should use this copper annealed. So now the ground is clear. Now we'll just go to the patch sizes. The patches are clicking on the cylinder, pressing escape. Patch, I will just name it a patch. The outer radius will be R, 0, 0 and 0 in centralized, 0 to T, and the segments. Okay, so R radius, what is the radius? The radius is 2 mm for this one design, and you can see it is clear. So you can just verify it at every stage you are doing correctness or not. Okay, so this is made. There will be 2 slots in the center. So pressing on the brick and slot 1, minus SW by 2, SW by 2, minus SL by 2, SL. You can even place the values directly here, like 4 mm, whatever. But if you use the variables, you can change it on the go, like here. So that is a very good way to just design. So that will be helpful to you. And SW value is 0.2 mm, and the SL is 1.5 mm. So let's see how it goes. Okay, like it is the vertical, so other one will just remove this one like this. So I will just change the material to the vacuum, so it can give me the directly this value. And the other way, I will just do the slot. I will do another way of designing it. So clicking on the vacuum, it will automatically tell me that they are different materials. So what to do? So you can say the cut away the highlighted part, highlighted shape. So it just cuts itself. Okay. So now just draw the other one in the horizontal direction. Slot 2. That will be minus SL by 2. SL by 2 minus SW by 2, SW by 2, and 0 3. In this way, I'll just keep it vacuum OK, but I will just press the pencil. So this is also drawn, and click on OK. This time I want to just do the none, so to tell you another way how to just cut the things using the Boolean function. So it is drawn, but it is not cancelled out. So I will just what I will do is that I will press on the patch, and I will click on this and subtract this slot 2 and press enter. So yeah, it is done. So this is how your one of the unit cell is designed. Let's change other settings. Frequency is the millimeter wave, so 24 to 30 is a good option for us. Less the boundaries. Okay, the back side is reflective, so don't need to change it here. But here you should just press the size of the substrate. The maximum dimension of that is the A. So A is that I have just pressed it. So it just so you have correct values of the substrate, the phase and the amplitude when you simulate it. And here what I will do, this ET is equal to 0 because the conductor, so I just don't need to just collect the simulate the backside, because I know it will be reflective as it is a complete ground, so that results are redundant. You can just leave it as it is, but it will take more time to simulation, and their result will not tell you anything. Like it is really reflective, and it will reflect all the things, and the phase will be absorbed, so it will be of no use. So rest what you can do is that if you are on a simulation machine, what you can do is that you can click this is the thing, acceleration, and you can just add it to make it to 8. That is a way, but right now on the laptop, so it's better. It will do it is a simple structure, so it must not take a lot of time, but let's see how it goes. But on the laptop or machines, you can just change the acceleration to 8 CPUs, or so it will be much faster. So let's start the simulation and see how the result goes. So like if you are having trouble in any of the paper or structure in CST, particularly in the Metasurfaces, reconfigurable intelligent surfaces, frequency selective surfaces, you can comment me or you can email me those structures, and I will try to design it. Rest you can comment on any question you have, and if you want to collaborate for research and publications, you can contact me on my email or comment here, and I will contact you. Oh, it's a quick one. So the results, okay, we got the results here. Okay, so this is the amplitude response. Obviously it is a symmetric unit cell, so the T and TM modes are both same. So Z max means the port 1. We don't have the min here because I just neglected it, that backside is ground, so I just cancelled it when I just changed the setting there. So max means the port 1, and 1 means TE, that transverse electric wave, and 2 means TM. So like this, sending TE and getting T1 from 2. So this is like S parameters, S11, S like that. So but like what does this means? This means that you send TE wave and you receive TE wave, and you send TE wave and you receive TE wave. So what does this mean? You send TE wave but you receive TM. So you can see that the response here is very low, so in amplitude. The same is for TM, sending a TM wave and receiving a TE wave. So like this, this is also, you can just also check the clicking on the phase. I can just check the phase response here. Let's just change it to dB. So now what I will do is that I will just using the same unit cell. In the start, I tell you that you can put the dimension, but when I use the variables, it has helped me that I can just change them on the go. So for changing the other design, let me just change the radius of the sphere from 1 point to 1.75. Okay, so I can just click on parametric update. It just changes it. And also the SL was 1, so I just changed it to 1. So let me just do it. So it has been changed. Now I will just rerun the simulation. So I just want that the old results are there. uh, it just didn't give me any. Sometimes it may give you a an warning or something like that. So just keep the old cache, so it just shows you both the results. I'm still hopeful that it will show me both the results, but if not, that in that way we will have easy comparison. Yeah, here I can just navigate between the earlier results and the new ones. So let it just complete and then we will discuss. So here the theta, let me also tell you in this, the theta and phi, you can use the theta and phi angular stability you can check by changing at different angles and see till which angle it can maintain its phase and amplitude that you want. So that is also a main property that is being used, because you don't want that only the normal waves are, because waves can come from anywhere. So you have to be having the 30, 40 degree, 50 degree, 60. Obviously when it comes to 90 it will be nothing. So but the more angle insensitive your unit cell is, the more use it has. So let's see. Yeah, we have these. Okay, you can see here we have two different sweeps, and let me just check the results. Okay, we can just okay, just this one is enough. Okay, the first sweep is giving us this amplitude. Both the amplitude are less than more than -3 dB, so it is a good reflection. So if it were lesser than -3, it would mean that -4, -5, it would mean that it is very lossy and it is not reflective. But we use a reflective unit cell and it is complete ground, so obviously that would also help. And above that there is a difference in the amplitude. So clicking on the amplitude works for us, and it is different, so it works for us in both the different types. And let's click on the phase like this. You can also use it like this, but what I mostly do is that for the actual difference I use the unwrapped. So I'm clicking on the minimum, and then you can just see here let me just click on this, sorry. So you can clear like this. If I just let me just press on 26 or whatever. So if we just subtract them out, 45 plus 228, so it is around 183. So 180, like whatever it has, 180 plus minus something, you can have some tolerance, and in those frequencies you can use it as a 1-bit difference, and you can just code your array according to that. So you can use it's better to save the I want to show you in the comparison, but it's better to save these in different, and then you can use it in an array. If you have any question, you can comment and contact me on my email. So that's it from my side. Stay blessed and take care.